Now, okay, so in the first lecture, do you remember I said to you that you cannot find real roots for all quadratics. Remember that? Shh. Listen. Okay, now, but in the complex setting, right? Okay, we can actually show that, but I'm not going to do that here. Okay, we can actually show that for every polynomial of degree n, there will be n complex roots. Okay, so some of these complex roots may or may not be real, but remember real are complex as well. Okay, and this n also includes repeated roots. So if I say 2 roots for x minus 1 squared, okay, this is 1, 1, repeated roots. I still consider that as 2 roots. Okay, I still consider them as 2 roots. Alright, now, okay, so this result is called the fundamental theorem of algebra. Just like you learn fundamental theorem of calculus, that just basically says that the reverse of integration is differentiation. Okay, now, so let's continue. Okay, conjugate root theorem. Okay, conjugate root theorem is this very special result that says this. Okay, if, this is new concept, please listen. Okay, if your polynomial has all real coefficients, that means you say things like this: 2x to the power of 5 plus 4x plus 6. Okay, so something like this, but not anything like this. So like this, no, I don't want. Okay, I don't want. Okay? Okay, so for this kind of polynomials with all real coefficients, including the constant term, by the way, okay, if there is a non-real root, so for example, very simple, x squared plus 1 equals 0. The roots are what? I and negative I, right? Okay, they are conjugates of each other. Right? So if your polynomial with all real coefficients has non-real roots, the non-real roots must occur as conjugate pairs. Okay, they must occur as conjugate pairs. Okay, so we'll use the examples to illustrate this. Okay, so let's look at example 4.3. Okay, now when you solve, you have this. Okay, so you realize that there is a conjugate pair. Okay, they will be in conjugate pair no matter what happens. Alright? Okay, and your GC can now come in again. Okay, your GC can actually solve for complex roots. Okay, so maybe let's take a look here. Okay, so again, apps. Okay, mine is Polysema 1, version 1. Okay, but it's similar. Alright. Okay, press any key. Okay, so I look for poly root finder. Can you do the same now? Do the same. Okay, now, if you go in here, okay, your interface will look a bit different from mine. You just key in accordingly. X squared plus 2x plus 5. So coefficients are 1, 2, 5. Okay, please remember to press enter after the last one. If not, it will register as 0 for A0. Okay, press enter after the 5. Okay, you have to change the mode to complex mode. Okay, which is, okay, let's see. Okay, my one cannot. Your one can. Okay, so if you look at your lecture notes, Okay, if you look at your lecture notes, right? Polysymol 2 app can, okay? When you go to your finder mode, there's a mode, right? Okay, instead of choosing real mode, you have to choose A plus BI. Can you please do this physically on your GC? Don't just read the notes. Hello. Okay, try on your GC, right? A plus BI, you will get the 2 roots. Okay, now, so let's go to the next one, which you do not have. Okay, you can solve this by using the quadratic formula. Okay, what I'm going to do here is I have solved by completing the square. Okay, by right I should have asked you to try, but I am short of time. Okay, please note you need to know both methods. Sorry, need to know both methods of solving. Okay, because later on completing the square will appear again and again and again and again. Okay, so you have to learn this method as well. All right. Okay, so you realize completing a square can also work even if the coefficients are non-real. Okay. Okay, so eventually what this will lead to? Okay, eventually what this will lead to, you will have 2 roots. Why? What is it? You cannot hear me. And you decided to tell me only now. Testing. Testing. Can you hear me now? Okay. Okay, so now you have 2 roots. Are they a conjugate pair? Yes or no? Yes or no? I and 2y, are they a conjugate pair? They are not. Okay, they are not conjugate pairs. Why? Why are they not a conjugate pair? Why? Huh? They are not conjugate pairs, right? Yes, the coefficient has a non-real root, a non-real number, sorry. Okay? Hey, I got a piece of bad news for you. Shh. Listen, but this piece of bad news is also very important for you. Your polysymol app cannot solve for polynomial roots if the coefficients are non-real. That means you say this, just now this screen, right? There is no way you can key in, say, I or 2i here. So I'm very sorry to say, if there are non-real coefficients, you have to do the things by hand. Okay? Okay, so I'll end off here. Okay, please go for your next lesson. Thank you very much. Okay, yes. Can you do the following? Let's see. Okay, actually no. Do this one instead. Okay, do this. The second bullet point. Find trigo ratios of angles in each of the 4 quadrants. Go and review this concept. Alright, okay, thank you. That's all. Go. If not, your tutor's going to say that I let you all go late.